All right, hello everyone. We're going to look at lesson 16. And for this lesson, it's really going to be just extending and continuing lesson 15. So you really need to have a hold of lesson 15 in order to understand this. So to begin with, I want you to, on your own, answer the first 9 questions. Okay, so 1 through 8 are the same thing over and over. And then number 9, I want you to see if you notice a pattern there. So go ahead and look through those, and then I'll look at them with you. So press pause, do 1 through 9, and then press play. Okay, which angle and side combination is marked right here? So what do we have? We have side, side, angle, or you could go backwards, angle, side, 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 angle, or angle, side, side. So we have SSA. Does SSA, based on our last lesson, actually prove that they're congruent? The answer is no, it doesn't. But do they look congruent? Well, yes, they do. Look at this. These look congruent. Let's go to this next one. What angle and side combination do we have? SSA. Once again, look right here. SSA. So once again, same as last time, SSA, but this time, do they look congruent? The answer would be no. Number 5, what do we have now? SSA, SSA. So you'll mark SSA once again. I think you're starting to see a pattern. Hopefully you're picking up what's going on. And do these ones look congruent? Well, yes, they do. And let's look at the last one. Once again, SSA, SSA. And do these triangles look congruent? No, they don't. So what we have is, no, they don't. So what it asks us, we know that in general, SSA cannot be used to determine congruence of a triangle. But in the previous examples, however, what did you notice about the cases of SSA that did seem to demonstrate congruence? So did this one seem congruent? We put no. Did this one? Yes. Did this one? No. Did this one? Yes. What do you notice about this and about this? They have that little marking in the corner for these angles. And what do those markings mean? That means you have a 90-degree angle. So what we notice when we use SSA, which isn't supposed to prove that they're congruent, if the angle that they share is a 90-degree angle, then it looks like SSA actually works. And that is the case. That's how it's always going to work out. If you have side-side angle and the angle is 90, the reason really is because with Pythagorean's theorem, a squared plus b squared equals c squared, if you were to solve Pythagoreans, you would get a side right here. You solve it, you'll get a side right here, and they'll end up with the same. So anytime this is a right angle, basically you're going to have the SSS criteria to use. But anyways, what I want you to understand is that anytime you're using SSA, it's not supposed to work, but if there's a right angle, it does work. So the main point of this lesson is this idea right here. What we establish here is that there is a version of SSA that can prove congruence, and we call it the hypotenuse-laid congruence criterion. Or for short, we'll call it HL. HL basically means that now we can use SSA as long as that angle is 90 degrees. So I want to make sure you understand this. Read number 10, answer number 10, and then go ahead and, so pause, try number 10, and then press play, and I'll go over it with you. Okay, so what do we need here in order to prove that these two triangles are congruent by using HL? You'll notice it already tells us that this side, KL, is congruent to KJ. These are congruent. And then KM is going to be congruent to KM, meaning each triangle shares that same side. So we have side, side, and then if we're going to use HL, that means we're going to do a side-side angle, and the angle they share needs to be a right angle. So they need to tell me this needs to be side-side angle, side-side angle, and this angle in here has to be a right angle. So the only way this would work is if KMJ and KML are right angles. You see this angle KMJ has to be a right angle. Angle KML has to be a right angle. If both of these on each side of that line are right angles, then we can go ahead and use HL. So that's the missing information. Okay. What can prove that these two triangles are congruent? Oh, you know what? Let's do this. There's only 4 questions left. So now that you have HL in your repertoire, you're going to go ahead and use all the congruence criteria. So this is going to put yesterday and today together. So now you have HL as well as the other four we used yesterday. So I want you to try this, see which ones you can use, and then when you're done, you can press play and listen to me go over it. Okay, so which congruence criteria do we use right here? They share this side right here, right, because it's the same side for both. So it's side, side, angle. So SSA. We're not allowed to use SSA. It doesn't work unless the A is a right angle. Is that the case here? Yes. Side, side, right angle. Side, side, right angle. So for that, we can use HL. Okay, when this one, you would think all it's marking is a side and an angle. But look right here. What happens when you have vertical angles? They equal each other. So it's actually side, angle, angle. Side, angle, angle. So SSA proves that they're congruent. What about right here? They look congruent, but can we prove it? We have a right angle. We have a side that they share. So we have angle, we have side. Do we have any other sides or any other angles? No, we don't, so we'd have to say none. And then last but not least, which congruence criteria can I use right here? I have a side that they share. Does anything mark any angles in here? No. Are any of the sides marked? No. It doesn't tell us anything's parallel. None of our tricks we've learned will work. So we're basically stuck with just saying none. All right, and that's the lesson. As always, email me if you have any questions.